Okay, now we want to discuss this programming concept, and this is the part where most of the students find it difficult to answer. Fine, so we are going to make this part clear, and sometimes it would be a lengthy video, so please cope up with that. So first thing that you have to understand is that program flow. We can understand, start our discussion from program flow. Okay, so see, you have to understand that we know instructions where they are stored in the memory, and we know each instruction, if it's a 32-bit processor, it would be 32 bits. Okay, so 32-bit bit made what? It's 4 bytes long. So each instruction can increase by 4 byte. That means, okay, maybe you want to understand. We know the instructions are stored in the memory. Okay, this is my memory. Let's say this is my memory. Now this memory, just kind of zooming it a little bit, this memory has instructions like instruction 1, instruction 2, instruction 3. It is stored in the memory. Now it's a 32-bit processor. That means each instruction's length would be 32 bits. 32 bits means we know 1 byte is equal to what? 1 byte is equal to 8 bits. 8 bits. So 32 divided by 8 would give us what? 4. So that means total in 32 bits there are what? 4 bytes. This we have understood. Total in 32 bits there are 4 bytes. So each instruction is 4 bytes long. 4 bytes long. So the program counter has to increase from this instruction. After this instruction finished execution, it has to go to the next instruction. So if it has to go to the next instruction, it has to, from the current instruction address, if I add 4 byte, then only I am going to get the next instruction, because each instruction has to be 4 byte long. Now from the instruction 2, if I wanted to go to the next instruction, that means this instruction 2's address plus 4, if I do, only I am going to get the next instruction. Okay, that is what it is saying. That is the programming flow what we are talking about here. So that means if my first instruction, this is my first instruction, that is adding this instruction. This instruction means what? This instruction is adding S2 plus S3 and storing their result in S1. So here what happens is that my current instruction is what? 0x538. 0x538. When I add to this 0x538 is my instruction. So 0x538, when I am adding here 4, 8 plus 4 is what? 12. In hexadecimal we will represent 12 as C, right? So we have C35. Fine. 0x53C you have. 53C you have, because we are going to represent 8 plus 4, we are representing it in. So the next instruction would be in this address. Now this plus 4 is what? See guys, C plus 4, if I am saying 12 plus 4, it's 16. Okay, 12 plus 4 is basically what? 16. So here if you see, we can represent only up to 15. We can represent only up to 50. 15 is what? F, right? We can represent only up to 15. That is one thing that you have to understand. We can only represent up to 15. We cannot represent more than that. So when I am adding, I got here 16. When I add 12 plus 4, I got 16. So what is the hexadecimal form of 16? 16 in hexadecimal would be what? For that I have to find the 16 in hexadecimal. So 16 in hexadecimal, how can you calculate the value of 16 in hexadecimal? That you can do by, see, 16 is here with me. I'm going to divide this 16 with 16 itself. I'm converting it to hexadecimal, right? That would be 1 and the remainder is 0 here. Okay, so that means 1 0 is 16 in hexadecimal. So if in that case c plus 4, if it is 0 will come here, and you have carry, that is 1. 1 0 means 0 is here and carry is 1, so that means 4. So 5 4. So 5 4 0 you will get. That would be the next instruction. How we did is that up to 15 only you can represent till the alphabets. When you get 16 and all, what you're going to do is that you're going to convert this 16 into hexadecimal. So when I did it, I get 1 and 0. So that 0 I will write it here, and carry would be 1. So 1 plus 3, 4 will come here, then 5. Understood? This is how you are adding. So in this way you have added, and this program counter, how the next instruction is calculated. So the next instruction is calculated by, in this method, current address plus 4 you have to do. Then you will get what? When you do that, you will get the next instruction. Understood? And this is done by whom? Program counter. I told you the program counter is going to keep track of the current instruction. So you have to understand that after execution of one instruction, the program counter would say do PC equal to PC plus 4. So that is, program counter would automatically do this for fetching the next instruction. So this is how the programming flow is basically there. Okay. Now so I hope you have understood the programming flow, how the instructions are basically executed. The program counter would automatically calculate the current instruction plus 4 to find the next instruction. Fine. Now logical instruction. Logical instruction, if you understand here, logical instruction is the performing bitwise operation. Logical instruction is bitwise operation. So what are the different bitwise operations? And, or, XOR, and, or are the different bitwise operation. That is basically the bitwise operation. Means each bit you're going to, that means there would be 2 operands that you can work on, and we will store that result into a destination register. So you have to understand that there would be, in bitwise operations, each of these bitwise operation can operate on 2 source registers. Okay, just going to operate on 2 source register, and the result is basically going to stored at the destination register. So it's going to operate on 2 source register, and the result is going to be stored on the destination register. So the main thing that it can do is that here, if you have 2 source register, let's say you have S1 and you have S2. If I'm doing AND operation, means each of the bitwise you're doing AND. 0 1 you get 0, 1 1 AND is what? 1 itself. 0 1 AND is 0, 0 1 AND is 0, 0 1 AND is like that. Or also you're going to do XOR is also you're going to do. If you have same thing, you're going to get 0. Same thing 0. Different things you have, then you're going to get 1 in XOR, right? So this is how you're going to do. So that means you're going to do the S1 and X2 and store their result to X3. Again you're going to do S1 and X2's OR operation and store their result to S4. So S4 would show its result. Now doing S1 and X2's XOR, and you will get the result in where XY. XY would show that result of that instruction. Okay. So here if you see, AND is also called as, AND is also useful for masking bits. Okay, masking bits. And OR can be used for combining the bits, and XOR can also be known as inverting the bits. So these are the different names you can say. AND is where AND is useful for, or where OR is useful for, where XOR is useful for. We can say AND can be useful for masking the bit, because some, like whenever 0 comes, it gets 0, masking it, right? And also for combining, means 0 and 1 come, you're combining it and you're getting 1, right? So combining. And for inverting, sometimes A XOR 1 can give, if I am writing A XOR 1, that means it is not of A. So it can also be used for what? Inverting the bits. Just you have to know this. Okay, and is used for masking, or can be used for combining the bits, right? If I can combine this with this. These are different address in the hexadecimal form it is given. So in order to do the operation, you can convert each of this into binary form. Okay. Now shift instructions. Shift instruction means we can move the bits to left or right. That is what shift. So you have different shift instruction. Shift left logic you have, shift right logic you have, and shift right arithmetic you have. Now what do we mean by each of them? Shift left logical means you're going to shift the bit to the left, and when I am shifting the bit to the left, I am moving all of the bits to the left. So some bits would be left at the right side. So the left bits you're going to add 0 to the right. You can understand this with an example. Now shift right logic means you're going to shift the bits to the right, and in the left side you're going to add 0. Now shift right arithmetic means you're going to keep, now these are all unsigned integers, unsigned numbers basically. Shift left logic or shift right logic and all work. Now shift right arithmetic means you're going to shift to the right and you have to keep the sign bit. That is the important thing. When you're shifting anything to the right, it's important to keep the sign, because this works in sign, while shift left logic and shift right logic and all basically works on the unsigned cases. Fine, this basically works on the unsigned. Now next we have sometimes we have done addition. So right now we got 16, which we said it is 10. Now let's say sometimes 17 comes, and now let's say I am adding 17 and 1, so I get 18. Let's say I got 18. So 18 means what? When I add 18 means, if I consider 18's when I am doing with 16, I got here 0, 0, 1, right? So how you can do with 18? So whenever you get 18 or 19 and all, how we are going to do? So here if you see 7 plus 1, 7 plus 1, what you're getting is 8. Okay, when you get 8, if you see this 8 means what? 8 you can write it as 8 itself, right? 8 you can write it as 8. There is no carry. Now when I am saying, let's say 19 plus 1 I am doing, I get 9 plus 1 is what? 10. 10 I can represent it as A, so I can just write as A and 1, like that. See, in the case we have done what? 16. What we have done was, we was having 12 and that we add with 4, you get 16 and 1. Okay, so here if you see this 6 is there, and then 1 came. So here what happens? 6 is there. 6 is there is a carry. Yes, there is a carry. But here if you see 19 plus 1, it is carry is there, like that. Like that you have to do. That means whenever you are getting, let's say my F15 games, okay, but this is the case, but when 15 plus 1 I have to calculate, that is 16. So 16 as a whole I have to take. So then I will write it into the decimal form, I get 0, 1, then carry would come. But if it is one digit like this, 9, 1, 2, 3, so that means carry is not there. Understood? But when I am doing like 60 F and all, carry would come. Okay, this is just the addition part. Just you have to just refer to the hexadecimal addition part and all. Okay, so now let me just delete this. That means if you have doubt in hexadecimal addition part, I told you, whenever if I'm adding C, F, D and all with any number, then we will do the method that I have told you, right? C means what? 12. So 12 plus 4 we get 16. Then I converted into hexadecimal form. Then that means 0 is what you're going to write and 1 would be the carry. Only when I'm adding with these kind of things, alphabets. But simply if I'm adding 2 and 3, I get 5. So I can write it as 5 here. No carry is there. That is what I mean, okay, while saying that. Now shift left logic means you're going to, T1 and T2 is there. So you're going to do shift left. Left direction you're going to shift and put the result in T0. Shift right logic means in the right direction I am going to shift and put the result in T0. Arithmetic means that here you have only like 2 of this signs, right? Here you will be having 3 because we are doing arithmetic. So sign is important here. In shift right arithmetic, sign is important. Fine. So here you can see with the help of the example itself. Here if you see, okay, that is S1 and S2 is there. Okay, so I am going to do shift left logic. That means I am going to shift to the left, and let's say the shift amount is given to me as 2, that I can shift only 2. That is that S2 is what? S2 is what? This value is what? This value is 2. So I'm shifting this S1 to the left by 2. That means this and this 0 would go, and this 0 we have to represent this. So that means this 2 would go, right? And then what I'm going to do, this 0 to S3 I'm writing the result. Okay, so through the S3, so this 0 would come. Now this 0 would come, this 0 would come here, this 0 would come, this 0 would come, this 0 would come, this 0 would come. Now this would come, this would come, this would come, this would come. Now this would come, because I have removed this. After removing whatever is left, that I am writing here, as you can see, right? Whatever that 2 I have removed, then whatever to the left side I have removed. So whatever would come would shift to the left, like how you can see, right? I shift to the left. Now this 0 1 comes here, this 1 comes here. Now this 1 would come here, this 0 would come here, this 1 would come here, and this 0 would come here. Now we have 2 places left at the right. That remaining place you are going to fill with 0 in the right. Now here if I am doing shift right logic means I am going to remove this 2. Okay, I am removing this 2, and whatever left here would come here. That is this 0, this 1, this 1, this 0. Fine. Then this 0, this 0 to the right I am shifting like that. To the right 2 things are removed, and I am putting the rest of them like this. See. So to the right I have shifted, as you can see. To the right I have shifted this. Now in the left there would be some spaces, 2 spaces left. So that spaces in the left which is actually left out there, you're going to, so this means this 2 spaces left, that you're going to fill it with the 0. Now shift right arithmetic means I'm removing the 0 and 1, and if you see the last bit should be always 0, because in my signed, this is the most significant bit, right? So the signed bit here is 0, so that I have to keep as 0 in the last. If the last bit here is 0, here it was 1, that means I have to keep here in the 1. Last bit should always keep 1. That is what doing the shift right arithmetic, and we are doing the left part, you are filling it with 0, but here you can fill it with 0 because the last bit is 0 for S1, but sometimes it can be 1 for showing the sign, then I have to fill it with 1. That is what you have to understand. Now immediate shift instruction means, the immediate value is already given. That means here T1 I have to shift to the left by 23 is directly given to us. It's not, we are not taking it from any registers and all. The value that you have to shift is directly given to us. Fine. Similarly, so and I have to store the result to T0. Now similarly, right logical also, the value I have to shift to the right is given to us directly. That is what immediate means. Shift left logic immediate, shift right logical immediate is what that means. Shift right arithmetic immediate, this is what it means. Directly that number is given to us where you have to shift. In the previous cases, as you can see, the value in the register we have to take and find out that value in the save register. Understood? So that is the difference between shift left immediate and shift right immediate and all. Okay, so this is kind of lengthy. Till now I have the 20 minutes of the video, so it's kind of lengthy. I will do the next part in the next video. Okay, thank you.